Right, now we're here to talk about generators, and I'm thrilled that there are so many people here. I actually didn't expect so many people, which is why the police sit up front is there. But before we get to generators, we need to talk about arrays, because that's where all of this starts. I think what's important for us to understand is where generators come from, what they're made of, how we use them, and then we can look at a really weird way to use them that I think is actually pretty awesome. So before I do any of that, the most important takeaway for you from this that I want you to remember is that we're used to spending a lot of time waiting in PHP. It's a synchronous language. But my hope is that at the end of this talk, you will understand what you need to see how we can write asynchronous code in PHP without extensions using generators from PHP 5.5 and above, which I think is a really cool thing to take away from this. But what about arrays? Now, hands up if you're not a PHP developer by day. That's great. OK, so you're all used to using arrays. I expected as much, but you're all used to using arrays, right? It's not a normal kind of data type like a string or an integer or Boolean. It's a list of data types. We don't have typed arrays in PHP. There's been recent talk about getting something like typed arrays implemented through generics, but we're stuck with an untyped list in PHP. And we've got control flow structures to be able to walk through them, like we can do a for each loop. We can loop through these things using fors and whiles and do whiles and all those kinds of things. And we've also got some helpful PHP functions, which will tell us whether a variable that we don't know the type of is or isn't an array. We've got lots of functions in PHP as part of the core language that work with arrays, like array filter and array map and array reduce, and these are pretty useful for us. And if we run this, we can see the normal control flow works as we expect. Is array returns true. That's all fine. That's what we're used to. But there are also array-like things in PHP that we use very often. If you've done any XML or HTML work, you've probably used the DOM document class. We can load it with some HTML, and we can query it by XPath or using a function like getElements by tag name. It's very similar to what jQuery was like in the old days, I guess, where we can query from a really deep hierarchical document and find elements with it, change elements, that kind of thing. But it's not an array. We can use it like an array, but it's not an array. This is array at the bottom here. If we run that, we're going to see returns false. So PHP has more tools for us. In the days before PHP 7, we would have to do something like elements instance of, I can't spell, instance of traversable. And that will allow us to see if something is traversable, even if it's not an array. Recently, we've gotten the ability to do something like, that's not what I wanted to do. Recently, we've gotten the ability to do something like is iterable, which is a more functional approach to doing the same kind of thing. And this will accept an array or an array-like thing and give us true. So that's a useful tool for us. Unfortunately, as we'll see later, there aren't many functions in core PHP that we can use easily with arrays that we can also use with iterables or with anything that's traversable. But we'll see that later. What seeing code like this led me to think about the first time I saw it was, can I make my own collection kind of things? Can I make a typed collection? And if you were from an age where the way to tell if something was traversable was actually just to say instance of traversable, then maybe your first thought was, well, maybe we can implement this interface. Of course, if you do that and you try and run that code, you're going to get an error, because traversable isn't a normal kind of interface. The error will tell you where to look: implement iterator or implement iterator aggregate. These are tools we can use if we implement them correctly to make our own array-like thing and to be able to extend it with our own functionality into chain method calls and so forth. Now to implement, let me copy that because I'm a lazy programmer. To implement iterator, we have to implement a few abstract methods. The error message we get from this will give us a hint to what that is. It'll tell us 3 of them. But there are 5 methods we have to do here. Function current, let's see if I can remember them all as nervous as I am. current, key, rewind, valid, and the last one is next. Thank you. My nerves get the better of me. We can implement these methods, and they tell us something about how PHP is thinking about an iterator. You see, an iterator, as PHP understands it, is a way to decorate a list of information and to abstract the concept of having a cursor pointing at that information. So when we create a new iterator object, that internal pointer, as it's implemented, points at the first item in the list of data we have. And we can use a function like next to step to the next item. Current will give the value, key will give the value, of the key at the position that the cursor is. Valid will tell us when we're right at the end and there's nothing more to iterate, and rewind will take us back to the beginning. So it's kind of like a forwards-only, cursor-based list traversal system. I don't want to implement all of these. I want to show you that this works when we have these methods here. So I'll run that just so you can see there aren't any errors. But it's not going to output anything because we're not storing any data here. I want to cheat a bit, though. I don't want to implement these methods. I want to implement iterator aggregate. This is a lot simpler for us to implement because now we just need to store some data internally. Pirate. We need to store that, I guess, through a constructor is probably an interesting way to do it. My nerves. Data. This data is data. And we need to define one abstract method that is part of that interface, which is getIterator. So now we can return any other kind of iterator, and iterator aggregate interface will be happy. Again, I'll cheat and I'll return just an array iterator. I'll talk about where this comes from in a little bit. But if we do this, it should satisfy the requirements of this code down here. So let's save that and let's see if I haven't made any syntax errors. Okay, there we go. Zero-based indexed, we have our 3 values here. This is a cheaty way for us to make something that works like an array and we can use in for each statements, but it's not an array. It's something we can customize. So you can tack methods onto this if you'd like. You can override the methods that'll be called from array iterator. And we can see this still also is an instance of traversable. If we look down at the bottom, Boolean true. Right. Before I move on, there's one more thing I want to look at from this. We're using this array iterator, but I just want to make very clear what's going on here. Var dump get class methods. And I'll just use this array we have here, because I want to show you where those 5 methods are. This is important for us, or for me, I guess. Here we go. There's lots of methods that array iterator gives us, but the core ones that we're interested in are these down here. Array iterator is an iterator. It implements that interface, and it has these methods, and these are a predictable part of this that we can deal with. We'll see why it's important for you to see these now in a little bit. Now, if you are tempted to make your own iterator, first go and look at the standard package library, or SPL as it's commonly known. There are many, many pre-built ones there, and you're probably going to waste your time, 90% of the time, implementing something that's over here already. So have a look how this will work for you first. It's standardized, it's tested, you don't have to maintain it yourself. But back to what I was saying earlier, there are a lot of functions in PHP core language that work well with arrays that don't work with iterators. You can't, for instance, take an instance of an iterator and pass it through array map. But you can use a library of Nikita Popoff's. Nikita Popoff, core contributor to PHP, very, very, very clever fellow. He's done other things which we'll see later in the talk, but this particular library is pretty fun. You can find methods in here that mirror the functionality of the core PHP array methods, but they work with arrays and iterators and generators. So you can abstract the code that you would be using from PHP core to use this, and then you can swap in iterators and generators later on. This is pretty cool. There's a bunch of extra functionality on top of the core functions that are abstracted with this, which I cover in an article from a long time ago, actually. And one of the most impressive things I saw when I started using iterators and generators over normal arrays is that you tend to write code that consumes less memory at the peak. But we'll see an example of that. However, we're here to talk about generators, so let's talk about generators. Now that we know where they've come from, let's look at how similar generator code is to array code that we may be used to, and where the benefits lie. This is an example of a function that reads every line of a file. So we would use it like this, that file path being where this code is executed. Don't worry about where that is. But we can define this function with an array for lines, open a handle to the file. Until we reach the end of the file, we can get an individual line from it, trim that to get rid of the new line at the end, and add that to the lines array. Once we've done that, we close the file handle because it's good to clean up, and we can return the array of lines. So we can use this as an array, or at least as a source for each, because what we're returning is an ordinary array. We run this, and we can see the contents of this file. There we go. It's pretty straightforward. Now, if we want to turn this into a generator, we mostly have to delete code. This is one of the ways in which generators make our lives easier, because we can make very simple functions, where before we had deeply nested loops and so forth. So to make this into a generator, we would do something like remove that array. Instead of appending to the array, we would yield at this point, and we don't even have to return the final array at the end. I want to run this, and if it runs successfully, I'll talk about what's different. Prefer to bug fix before I start explaining. There we go. Okay, so it runs exactly the same way as it did before, but what's changed? Well, when PHP sees the yield keyword, it starts thinking of this function pretty differently. What gets returned from this function isn't the value of that array, it is a thing called a generator. So on first execution, the file will be opened, and it'll go past this line, but the moment it sees the yield keyword, it does a kind of return. We can think about it as a return of the first value of this. And then it stops executing the function entirely. It doesn't do this. It doesn't go to the next iteration of the loop until the next value is pulled out of the generator. OK. So we can still use it like an array. It's not really an array anymore. But there's a hidden benefit to this, which I spoke about earlier, which was that the memory consumption is less. The previous version of this function stored every line of the file that it read in an array. And it had to do that before it could return to us, which means the whole file contents was in this array. For a small file like the one we're opening, it's not such a big problem. Maybe in a memory-constrained environment or a highly parallel environment, it would be a problem. But for now, it's not, because it's a small file. However, with the generator alternative, we only read one line and keep one line in memory, as well as the open file handle. So we're not storing as much in memory. We're not reading the whole file into memory. We are over time, but it doesn't all get stored at once. I need some water. This is intense. Right. Let's look at a more complex example. I want to demonstrate a couple more features about generators. So we'll look at bubble sorting. Bubble sorting isn't too complex of a thing. It's a sorting algorithm that is pretty inefficient. It's O(n)². And that basically means it's going to do n amount of work for as many items as there are that it's got to sort. How it does that is it takes a list of values and it compares the first with the second. If the first is greater, it swaps them. And then it compares the second with the third. And if the second is greater, it swaps them. It does this as many times as there are items in the array. Worst case. Best case, as we'll see, is often not that bad, but it's a good example because it's very difficult to mess up what the algorithm does. Now, this is it implemented as a loop. It's probably not a typical example of generators. We call the function with an unsorted array, assign that result to sorted, and then we dump what that is. So, what we've done is we've gotten the number of items in the array, and that many times we have gone through comparing each, modifying the input array, And right at the end, we return all the sorted values. And so though we start with 1, 6, 2, 5, 3, 4, what we get at the end is 1, 2, 3, 4, 5, 6. So our sorting function works. How would we turn this into a generator? Why would we turn it into a generator? The first is probably easier to answer. We can return the sorted values right at the end. That doesn't need to change. But we can also stop at each step and see how the array is changing as it goes through. And to do that, we would just yield values. Values, values, yield values. So now when we do this and we execute the function, what we get is not the final values yet, but it's an instance of a generator. We may as well rename this to steps because that's more accurately what it is. And we can change how we're using it by remembering those functions that exist on iterator. And we'll see why we can use those functions now. But here we can say steps valid. So while the steps are valid, in other words, while there is still iteration that can be done, then var dump steps current and steps next. So we get the current value and then we step over to the next value. I saved that automatically. Oh, I didn't even mean to. Okay, there we go. So 1, 2, 5, 3, 4, 6. 1, 2, 3, 4, 5, 6. It's a really bad source array, actually, because it gets sorted in 2 iterations, and we still have the n squared to worry about at the end. But now, instead of just printing the final values, we can print the steps in between. And it was very easy to turn this function into a generator to be able to check out those steps. This isn't as important as what we can learn from what makes up a generator. Var dump get class methods of that instance. I'll stop this printing out for the moment because I want to show you something interesting. Have a look at these 5 keys here. It's exactly the same ones that we've come to expect from iterator. And that's because at its core, generators are nothing more than syntactic sugar on top of iterators. They're the iterators we don't have to write. We can just think of normal loops and points at which we want to return values, and we can use generators like that. There are a few more which are far more useful when it comes to asynchronous code. I'm going to focus specifically on send and throw, show you how those can work. So our bubble sorting is still a generator because we still have a yield in there. What's interesting about generators for me is that you can send values into them while they are iterating inside them. In the middle of this loop, we can actually send a value into the generator. To do that, we can hijack this thing that we had before, but instead of calling current, we can call send with a value. So how do we access that inside a generator? Probably the most tricky thing about understanding this aspect of generators is that yield not only sends a value out of the generator, but it can accept a value into the generator by using the send method. So we can assign the value of this and also send a value out at the same time. The yield part happens first, so the value goes out the generator first, and then the send comes in. Let's var dump this. Now we're only going to see one iteration, but what we're hoping to see is the value we sent in. So we can send values in. We can also throw exceptions in. So I'll just take this code. We can also throw exceptions in using the throw method. And the way that we capture those is not with assignment, but with a try catch. So we catch the exception without syntax errors, hopefully. And here we can use getMessage. Let's change that message because it's a bit deceptive at the moment. Oops. There we go. So we can send normal values in and capture those by assignment. We can throw exceptions into the generator and have it handle some exceptional state inside the generator. What does this mean for us? Could someone give me a definition of what a pure function is? Who's feeling brave? Pure function. It's not a trick question. Pure function?
Pure function is a function that always returns the same output if the same input is given and produces no side effect.
Yes. Sometimes also called a referentially transparent function. I think if I'm... So that's what pure functions are. Good definition. Thank you very much. They take the same input and they always give the same output. They don't cause side effects. They don't depend on external state to give their return value. Pure functions are like data tables. With the same input on the left-hand side and the same processing on the top, they give the same output. It's the same as looking up in a table, giving an X of input parameters and a Y of functionality. It's an interesting way to think about it. And what we've been seeing is that iterators and generators make something kind of like a lookup table where they determine the value that gets returned each iteration. Could we think of functionality like this, behavior? Could we think of behavior as a lookup table? If we swap the values and the functionality and get something like this, with the same input parameters and the same expected output, could we determine the behavior that needs to be executed as a lookup? It's a very strange way of thinking about it. But what I'm going at is that generators and even iterators give us the ability to wrap behavior, things that would typically block. Large tasks separated into smaller tasks, to wrap those smaller tasks in iterative steps. I want to make something for you to demonstrate this idea to you. And I want to have some scrolling, so I'll make some clear lines. I want to make an asynchronous task manager that allows me to make little pockets of behavior, little pockets of code that I want to run, so that I can break down a big task into a small task, have many of those big broken down tasks, and interpolate their functionality. I'm going to need two classes. The first class I'm going to need is a task. This will store a generator, which I'll call work, and we'll take that in through the constructor. Now, I'm going to make an assumption here. You probably want to type hint or type check, but I'm going to make an assumption here that we will get a closure and that it will generate a generator. So I'll say this work is the return value of executing this function. Okay? That's an assumption I'm going to make. You don't have to make that. You can. It's safe. It's safe in the case of this example. Okay. Now our task needs to do two things. It needs to tell us if it's done all of its work, which we'll call valid to mirror the behavior that we've come to expect from iterators and generators. So we'll give it a valid method to say if there's still more work to be done. And it needs to run one unit of work. So we'll call that method run, and it'll do one tick of the generator. Public function valid. And public function run. And what does it have to do for one tick of work to be done? This work, next. Okay. This looks a bit confusing for the moment, but let's look at what the task manager does, and we may get a deeper understanding of what's going on. Class manager. Now this stores a private list of tasks. We need a way to get a task on there, so I'll call that add, which I can type in because I'm happy with this type in. And what we want to do is we want to put a task on the beginning of the list and try and create a kind of first in, first out system going here. So what we'll say is array unshift with that task. And we need one more method on the manager, which is the one that starts all the work off. A run method on the manager, if you like. Now, what determines if there's still meaningful work to be done? Maybe one definition of that is if there are still tasks in this array. So if any tasks have been added, and they're still in that array, we still have work to be done. So we could say something like while count this tasks. So while there are still tasks in this array, fetch the next task. Because we unshifted them to the beginning of the tasks list, we can pop them off the end. And we can run 1 unit of work. After that, if there's still work to be done, let's add it back to the manager. Because that'll unshift it into the beginning again, so that we can pop it off later on. Okay, so we've got our task class. I'll revisit this in a little bit. We've got our manager class. We don't need to do any more changes to this. It is perfect code. We don't even need unit tests. But let's make a couple tasks. So I'll say new task, and because now we only expect a function that makes a generator, we don't have to immediately invoke this. I'll make this a really simple task just to illustrate the point. For I is 0, I is less than 5, I plus plus. Here we'll print something like task 1 just to know which task we're in, and let's print a dynamic step value. Oh, and a line break. Now to make this into a generator, we have to have a yield here still, but we're not yielding anything meaningful for the moment. We can duplicate this. Let's change this a little bit so that we can see some difference between the two. Then we need to make an instance of the manager. Do you? No. We could, but we don't need to. We can just add it like that. Because we initialize the array there. Okay, and finally, we need to run this. Let's take a quick look at this. There's task. There's manager. We're making some tasks and we're executing them. Okay, let's run this. Ooh, instance of task null given. What did I do here? When I'm adding it back, should have written tests, hey? Okay. Task 1, step 0, task 1, step 1. Task 2, step 0, task 2, step 1. Then we get task 1, task 2, task 1, task 2. Okay, it's almost where we want it. Noticing also there's a few more steps to do in task 2. It's almost where we want it. However, this is a prickly problem. And I'd like to know if anyone can suggest why. I'll give you a hint though. The problem is in the task class itself. Can anyone suggest why? Why do we do 2 ticks of task 1 and 2 ticks of task 2? Think about those functions of the iterator and the generator. I'll have some water while I'm waiting. No. It's not that. It is the next that's doing it. You see, the very first iteration, we already have behavior being executed. We call next immediately, and so it does current and next. It's doing 2 ticks of work when we only wanted to do 1. The solution is an if statement, of course. Private run. So the first time, we'll do this. If this run, well, this isn't the first time, this will be subsequent times. Else this work current. Now when we run this, it should interpolate as we expect. There we go, task 1, task 2, task 1, task 2. I'll show you something interesting, even more interesting than all of this. We've done this in 64 lines of code. We've made asynchronous code in 64 lines. It's probably a good time to clarify a difference in terms. We're used to synchronous code in PHP. We're used to writing a top-down list of instructions, executing instruction 1, waiting for it to be done, executing instruction 2, waiting for it to be done, and so forth. In other languages, it's commonplace to have language constructs that allow us to do parallel execution, which is not a list of tasks, but all the tasks at the same level, executing at the same time, different threads, different processes. What we're doing here is not parallel execution, it's just asynchronous. It's just interpolating small bits of work. This runs in one thread. So it's not really parallel. However, the concept is a powerful tool for a language-based abstraction about parallel execution. And we just get asynchronous for free. I'll show you what I'm talking about. But first, just a recap. Generators can be used as interruptible functions. We saw that. When the interpreter sees the yield keyword, it stops execution. We get a value out of it, and the next time we iterate over that generator, we do the next bit of work. So it's kind of like an interruptible function. And other languages have taken to calling this coroutines. And what I showed you now is that we can use these interruptible functions as a way of building asynchronous architecture in about 65 lines of code. It's not a lot, and the lines of code doesn't really matter except to say it's very little lines of code that we needed to be able to do this. We can use generators as far back as PHP 5.4. We can combine the generators in PHP 5.5, sorry. We can combine the generators in PHP 5.5 with the exec in PHP 4 and do asynchronous code that is also parallel execution. So we don't need extensions to do asynchronous PHP code. And bizarrely, this comes from a side effect of having generators to do programmatic incremental generation of data. Now, there are some clever people who have taken to using this concept to build entire libraries, have taken the ability to use yield and to create simplified non-blocking code that reads like traditional blocking code. AMPHP, or asynchronous multiprocess PHP, is my favorite of all of these. Sorry to the React fellas. Because this concept of coroutines is so interesting to me, and the alternative is callbacks and promises used directly. Let me go back here. This REPL that I've got here is actually the product of another site that I've been working on called preprocess.io. And preprocess.io is a site that runs on top of an asynchronous PHP HTTP server. It doesn't use Apache or Nginx as what we're used to. It makes its own server, similarly to how this happens in Go or Node.js. And the code to do that looks like this. This may be somewhat familiar if you've set something like this up in Go or in Node, where we specify an IP address that this responds to, where asterisk means any, and a port that this listens on. And so this acts like an HTTP host. We define a public folder to load static assets out of. We create a router, and we define some routes in a separate file and load those on the router. You know, where we define things like get and put and post and delete, those kinds of things we're used to from framework land. So this is how that works, but this works as a long-running process. And the entirety of the code base of preprocess.io uses non-blocking code and yields. So here's an example of one of the endpoints that respond to a request. I have this run function that I add in the routes file, and I've got many instances of yield. Let's look at this piece of code, for instance. This is a function defined in this trait. And what it does is the equivalent of $_post, fetches post values. But because requests and responses in this framework are promise-like things, we don't have the full request by the time it gets here. I need to wait for a multi-part request to come in fully before I can decode what has been posted. So parameters, and in fact yield this parameters, does that for me. It waits until the full request is available for me to start sniffing out the post parameters. Then I've got this compile. Now preprocess.io takes a superset of PHP and compiles it to PHP. So I'm getting post values from that, and I'm compiling it to a different version of code. And this compile, which I've commented out the code of or taken the code away from down here, what this compile does is it actually creates a separate process and does that compilation in a Docker container with a timeout so that people can't RMRF my server's files. But this goes to a separate process, and yet it's still non-blocking. You see, the moment PHP gets to yield, AMP is set up in such a way that it stops waiting and holding resources up here for these things, for these processes to be complete. It goes and it is able to serve other requests. It does that using abstractions for non-blocking I/O and non-blocking file reading and writing and all sorts of stuff, which is I/O. I don't know why I repeated that. So here is an asynchronous process that starts a different actual machine process. The same thing here where the code is executed. And right at the end, I have an asynchronous way to respond to requests because sometimes I want to fetch data from the database, for example. This is actual code running in production. And this isn't the only site that I've got running like this. It is possible using yield, using generators as coroutines for us to write code that looks relatively straightforward. This looks very similar to the kind of synchronous blocking code you would see before, but it's completely non-blocking. And it's thanks to libraries like AMP who are using event loops in the background and non-blocking I/O abstractions in the background. So I don't have to think about how to write that. I can just use yield for something it probably completely wasn't intended for, but for a use that works well. If you like kicking it old school and using React PHP, but you also want to be able to use coroutines, there's this project called Recoil. It is an abstraction built on top of the abstraction that is React PHP. And in this example, what we're going to do is we're going to resolve domain names asynchronously. So you can load in a wrapper around the React PHP event loop, and you can define a function that creates a generator. And what this is a promise-like thing as well. See, React PHP also has an implementation of promises. And in JavaScript, you may have used promises and be used to being able to call a function on the end of a promise and give it a closure and have that executed when the promise is resolved. Well, that code still exists in React PHP, and it's cool code. But using this recoil abstraction, we can now yield that promise. And so IP will only get assigned the value when the promise resolves asynchronously, as it happens in parallel to the other work that's going on in the server. We create an instance of the React PHP DNS resolver and give it the recoil event loop wrapper. And then we can just yield stuff. And hey, it works asynchronously. It doesn't look very different from normal synchronous code. But because we're using yield and generators, we can do that. I think this is great. You know, all of the stuff that I'm showing you, just so happens to work in JavaScript. We can use generators in exactly the same way in JavaScript. That task and manager setup that I coded in front of you, adding asterisks here and there, actually, it works in JavaScript. And there are a couple runtimes, I'm not sure, I think it is actually just 2 runtimes, that act like what AMP's codebase does, or what Recoil's codebase does. That take generators and that turn them into coroutines. So this knowledge doesn't just apply here, it applies in JavaScript land too. But they take it a step further, and they allow you to write code like this, async and await. So there we don't have to make the generator functions ourselves. We can make generator-like functions, and as long as we decorate the function on top of that in JavaScript, we can have asynchronous code without having to use promises directly. In a function like this, we may expect to read a file contents with asynchronous I/O, to highlight it with this built-in function, and to see what the results of that are. Turns out you can do a similar thing to this in AMPHP, or using recoil on top of React PHP to read your stuff asynchronously. But if you were to do it in AMP, you would have to wrap it with a function that turns a generator into a coroutine, a promise-like coroutine. So for AMP v1, that would be something like AMP resolve, and for AMP v2, that's something like AMP call. Now, if you go to preprocess.io after the talk, and I encourage you to, as long as it's not during someone else's talk, you'll see that the purpose of that site is to be able to allow you to make preprocessor macros on your code. So actually, you can write in a PHP superset language like this, and it will convert that code to something like this. Automatically decorating this, automatically type hinting the eventual value as currently an AMP promise. And I find it very difficult to talk about asynchronous code or to think about using generators as coroutines without also thinking about how close it is as a language to being able to do async and await. And that all it takes to do that is to move the great userland libraries, like those of React PHP or AMP, into core, or having some kind of primitive there to be able to do this. But for the moment, I'm going to have to stick with preprocessors and just write cool-looking code like this. This executes, by the way. This actually works. We have AMP wait here to be able to run what is essentially a promise within a synchronous context. But it actually works, which I'm quite happy about. Anyway, I think that's all. There are slides there. Please give me feedback to tell me what I did wrong and to tell me what you enjoyed about it. And please ask me questions. Yes, there's a question.
Who will use the generators, not the guild functionality, to implement actors?
To implement?
With guild messages. So if we were to bring the actor concepts of the actors
Yeah.
to PHP, then I think the generators and with guilding event messages, for example, we could do that.
I haven't tried, but I don't see why not. Not a helpful answer, sorry. I think we're out of time now, but afterwards, sure. Are there any other questions? I'm going to wait for at least like another 2 questions. So. No, I'll get to you now. Thanks. Could you show?
Can you show how do you implement the get parameters from the request? So you have the yield get parameter. How do you go about in the request object to generate the parameter asynchronously?
I will show you that code after I've answered that question because I have to go out the slides for that. Yes, there was a question at the back. Fantastic. Actually, being able to do non-blocking I/O allows you to have massively high concurrency in ways that you can't do using just Apache or Nginx. They're great software, but in order to get the same kind of concurrency that you have when you manage all the I/O in a non-blocking way, you have to do a lot of customization to the base Nginx and Apache. Whereas this code is portable, works anywhere. You can package your website up as a FAR file and run that as a long-running process. You have the same things to think about, like when you implement your own HTTP server in other languages, like memory consumption, because it's all one big file that runs continuously. You have to be more careful with memory than what you do just with normal PHP threads that die very quickly. But I've got like half a dozen sites running asynchronously now, and I just have I run them through supervisor D, the daemon, to pick them up again when they fall over. Not that they ever fall over. If I need to deploy, I have to kill the process and let it start up again to get the new code running. But I mean, they're super stable. And the higher concurrency is an immediate payoff. Unfortunately, there's no documentation about how to do this yet in a holistic way. There's docs about specific components, but to put them all together to say, this is how you go from the code you were writing to a completely asynchronous site with sending mail and handling registration and database stuff, that doesn't exist. But I'm writing a book about it. So if you want to know about that, follow there and you'll get updates for that. Getting parameters, yes. Okay, I'll show you the code base of preprocess. That's the end of the official thing, so thank you very much for being here. The site on which this REPL is running is an asynchronous site. And here where I get the parameters, this request object has a getBody method that returns a promise-like thing. So on top of here, you could say something like onResponse and give it a closure for something to happen when the full response comes through. But because we're using generators and coroutines, we can just await, which is string replace for yield in the preprocessor macros, and body will get its value when this promise resolves in a non-blocking way. And we pass the body and return an array of the results. It's a naive implementation because it doesn't handle multi-part well. It handles URL encode, which is what the front end uses for this. But I mean, this is an asynchronous function that returns a promise-like thing. It's just that I've got to do some extra processing, so I had to make my own async function that wraps that. Are there any other questions? Yes?
Yeah, just a small one. You showed before that there's the send and the throw
Yes.
methods on the generator.
Yes.
Have you seen any cool applications of how to use any of that?
It's a good question. Are there any applications for send and throw that I've seen that are cool? All of the recoil stuff and the AMP stuff uses send. It has to be able to resume functions. Yeah. In fact, it has to use send to be able to assign the results of a yield. So that's how that happens. I mean, I think that's a really cool application of it. I haven't seen examples outside of AMP or recoil that use throw.
Yeah. It's like kind of a cleanup of your.
Could be.
You shouldn't have any state, so.
Yeah. It could be. I can't think of anything offhand that's any other use for throw that I think would be useful. I have to admit, though, I am super biased in that the only thing I care about generators for is asynchronous code. So maybe there are uses and I just haven't spent any time on looking at them. Any other questions? No. Thank you very much for being here.